Alrighty, in the third video for 8.1, let's talk about how we are going to decrease the margin of error. In general, when we're making an estimate, we really like to have a small margin of error. That just makes sense. We like, if we have our point estimate, there is P, that is where we are estimating our P to be. We like these values, the interval, to be as small as possible. So one way to decrease the margin of error is the confidence level will have to decrease. So to obtain smaller margins of errors from the same data, you must be willing to accept less confidence. What that means, if we go from a 95% confidence level to an 85% confidence level, notice what happened to the confidence intervals. At 85%, we have shorter confidence intervals. I hope I could spell shorter intervals. Shorter intervals. When you compare the lengths of the intervals over here at 85% to the lengths at 95% for the same sample size from the same population, notice what's going on is these legs are now shorter. The margin of error got cut down. When we decrease the confidence level, we have less margin of error. But what happens also is, notice how many of these are no longer catching the true parameter, the true value that we want. Look how many of these are not capturing my true value. And on the left side, it was only 2. At 95%, we catch the true parameter, the true value, much more than we do with a lower confidence level. Because here, 95% of the intervals contain my parameter. On the right side, only 85 do. But we decrease the margin of error. So when it captures it, we know it captures it. Another way to decrease my margin of error is to increase sample size. So if we go back, the first thing we did here, decrease confidence levels. Decrease confidence level will lower your margin of error. And if we increase sample size, margin of error also goes down, because we are trying to lower our MOE, our margin of error. All right, so notice, again, same sample size on the left and on the right. Confidence intervals 95%, 95%. But what we went for, this is the better way, because sample size 25, sample size 100. Notice the one on the left, we have the longer confidence interval. We miss twice, but on the right, we only miss once. Notice what happened to my confidence intervals, because the larger the sample size, the closer our average, the closer our mean gets to the true value. Central limit theorem. Okay, so these have shorter intervals. And they are shorter intervals because of a larger sample size. And here we have longer intervals. Notice they have the same confidence level. Okay, so to decrease the margin of error, we can increase sample size or we can reduce the level of confidence. Let's talk about our critical values. So a critical value is a multiplier that makes the interval wide enough to have the stated capture rate. This is on your formula sheet. It says it like this. It's going to be whatever our statistic is, plus or minus our critical value, times the standard deviation of the statistic. So we are going to go over this more in the next part of our chapter, but we're going to get to that. Okay? So this is this part, the standard deviation. This, is known, the plus or minus is my margin of error. There we go. Let me get my highlighter out. That is my margin of error. Now, margin of error doesn't count for everything. So when we find our confidence interval, we have our margin of error because we expect the value of that point estimate to vary somewhat, right? It's going to vary a little bit from what I expect it to be. However, the margin of error only accounts for the variability from our random sampling. That is what margin of error accounts for. The variability, margin of error accounts only for the variability from random sampling. It does not take into effect. It does not account for undercoverage, non-response, anything like that. These problems are going to give us estimates that are going to be a little bit of an issue. So remember that. So remember this unpleasant fact. Margin of error does not account for source of bias. Anything that leads to bias, margin of error it doesn't account for, because margin of error only accounts for natural occurring variability in my random samples. Okay, so let's address this. Let's look at this. So losing weight, a Gallup poll again asked a random sample of U.S. adults, would you like to lose weight? Based on this poll, the 95% confidence interval from the population falls between 0.56 and 0.62. So I expect anywhere from 56% of U.S. adults to say yes, all the way up to 62% of U.S. adults to say yes. The true value is going to be somewhere between those. 95% sure of that. So what would happen to the length of the interval if the confidence level was decreased to 95%? So when my confidence interval is decreased, the length of the confidence interval is also going to decrease. And that lowers my margin of error. How would the width of a 95% confidence interval based on a sample size of 4 times as large compared to the original 95% interval? So I am making my second sample larger. So when I make a sample size larger, my interval cuts in half. We saw that. Not always in half, it gets shorter. So the width of my confidence interval, 4 times as large, would be half as wide as the confidence interval with the smaller size. And you might remember that because our errors always had either a square root of n on the bottom, or we did p times 1 minus p over n, and we took the square root. So making this 4 times bigger actually cuts my standard error in half. So a Gallup poll indicates that 3 percentage point margin of error for this poll includes any sampling variability, what they call sampling error. What other potential sources of error, Gallup calls these non-sampling errors, could affect my 95% confidence interval? So remember, errors are only because of normal variability in my samples. Anything beyond that would be a non-sampling error. So a potential source of error could include non-response. If people were selected and that they had different views, didn't respond. So I asked you, do you want to respond? And everybody else is saying yes. And I'm just going to go, yeah, I don't really care if I lose weight. I don't respond. That would change my estimated amounts. Okay? So we have gone through this enough to finish out assignment 8.1. And you'll notice in the next couple pages, I have given you a summary of everything we have talked about. So if you've got questions, that is a great place to start. And if you got questions, go ahead and ask me, Patriots and statisticians. I would love to help.